So I love the order of the presentations here because actually I would like to talk about this framework for change that Gameloft mentioned in the previous talk. So thank you everyone for joining me here. Just a little disclaimer. First of all, this presentation was first done at GDC in 50 minutes, so I had to boil it down to 15 now, so please bear with me, this is going to be a crazy ride. And second of all, I'm coming from the engineering background, so I would like to get to know you a little bit more. Who is coming from an engineering background here in the audience? That's at least some. Great. The problem is I won't be able to get into a lot of detail of the technical issues here, so I guess I hope I try to make it successfully understandable for everyone. So let's start. First of all, this was the project that I was joining InnoGames for, and I just want to show you a couple of screenshots here to visualize how many different UIs we had in the game and that were supposed to be done. So the first step that I was doing was figuring out how was the process that we used before, and can we apply this for the new project as well. And the old approach actually, and I'm not sure if anyone recognizes that, in the previous days was our artists were coming up with designs in Photoshop, and they were focusing on their experience there, and they didn't really care for engines and kind of constraints of platforms. So they were throwing over their design to our UI developers that were supposed to implement the whole thing in any kind of engine that we were using before. So one third party that I don't want to forget about is the QA that actually had to test the build in the end and make sure that everything worked as it was intended initially. And as you can see already in this approach, we have a big issue that when you find a problem very late in the process, that means that you have to go back to the drawing board, in worst case scenarios, even redesign stuff in the Photoshop file from the start again. So in our new project, our artist that I want to introduce now was very disappointed with that approach, obviously. And our developers were also frustrated because they actually wanted to focus on their logic and on the game features there, instead of having to re-implement stuff that the UI artist came up with. And also, our QA was frustrated with that kind of stuff. And we will learn a little bit later how that improved in the new approach. But let's recap the flaws of the previous approach. So this not my problem attitude was the biggest issue, because everyone was just focusing on their stuff, throwing it over the fence, and then making sure that they don't have to care about the rest anymore. Our developers had to kind of play UI artist as well a little bit, because they had to re-implement something that was designed in Photoshop and had to make it work on different platforms in the engines. And obviously that is a problem as well. And another problem was that we made this developer basically focusing on that UI implementation alone. So we ended up having mostly untested code there, because they really didn't have any guidelines to work with, no architecture to follow, nothing. And on top of all that, as I showed you already before, this long turnaround times made it hard for us to actually iterate a lot on for example, tutorials, which obviously, as we learned before, need a lot of iteration. So in our new architecture, we wanted to make our artists work directly in Unity, implement everything directly in the engine, and focus on the constraints and the possibilities there. We didn't want them to ever go back to the developer and make them put a button 2 pixels further to the left or something like that. We also wanted to decouple the development and artwork so that the developer actually can focus on implementing the features and the artist can focus on implementing designs in the engine, and that they can work in parallel already, in best case scenarios already on the same screen or design. So how does this look like in reality now? This little video shows how our artist Ollie is now putting a new button into the screen that we see here. And he can do this all alone without ever talking to any developer. He just switches the old button to this new one. He put it to the right place. He changes the text accordingly so everyone knows what this button is supposed to do. And then in the interface part, this is what you see on the right now, he just drops the button to the right place and the text to the right place so that it can be localized. And that's basically all the interference, interface the two parties actually have. So our artist is very happy with that approach, obviously, and our developer can now finally focus on what he's good at, and that's the logic of the game. And we will see later how our QA is also loving this new process and why. So everyone is happy, perfect. But how did we get there? First of all, since I don't have the time to go into a lot of details. There's two patterns that we were inspired by, and that is the MVC pattern. Did anyone use that before or has any idea how that works? Great, because I can't tell you a lot about it. I just want to emphasize that this pattern allows us to separate our architecture into layers that are completely independent from each other. So we have the controller layer that is implementing the game logic. We have the model that is having the data in it, and the view that is actually visualizing that kind of data in the UI. So, for example, what you saw in the editor before, that was the view layer. And I have a little example here that I have to skip. And then we also found out about this MVVM pattern that has a nice little feature that we wanted to add to our system as well. And I won't go into a lot of detail, but you see this layer view model here, which is new to the picture. And what it brings us, or what it helps us, is that it kind of aggregates the data from the models so that there is a one-to-one relationship between what you visualize in the view and what you have in all the models scattered around the game logic. And what this allows us to do is to have this kind of data binding, which allows us to actually automatically update the view and the model layer and vice versa if any changes happen there. And we wanted to aggregate both of these patterns into our architecture. So our architecture looks like this. We have the view, which is completely done in Unity. What you saw in the video, basically, that is that. And we have this interface layer, which is called the view model, that allows the developer and the artist to never really interfere, which is also a plus in engines like Unity, where you don't want them to work on the same scenes. So what the view model does is it kind of connects the two worlds, model and view, together, and allows us to automatically update those both sides independently. One other aspect that I want you to focus on is this message bus underneath, because that is going to be important later. It allows us to control the communication between each layer independently. So whatever event happens, either if it comes from the backend or from the UI or from the game logic, it all goes through the message bus. Keep that in mind. A little example that I want to show you is this settings screen, and it's pretty straightforward. There's nothing really fancy about it. You just have to connect the values on the elements on the left with the right side, and in code, it basically just subscribes to a model and then connects the data from the model to the view elements. A more sophisticated example that is more complicated to do is this kind of buff list, which obviously has to be populated at runtime because the amount of buffs that are currently active are not determined at editor time. So what I want you to focus on is this buff entry on the right. It's a prefab, so the artist can actually prepare the list entries and design them how they are supposed to look. And the code in the end instantiates those list elements depending on how many are currently active. So the short example about this is that we can subscribe again to the model that contains the active buffs, and we can also define a method that gets called once this model changes. So in this method, this is just pseudocode. You can see how we just instantiate that buff prefab as many times as we have buffs active right now. Obviously, this kind of stuff introduces a new layer and a new abstraction. So the question is, does that have any impact on performance? And yes, it has. And to make matters worse, it's actually based on reflection. So this is going to be an OO in Unity and C#. But we managed to make this all at startup only. So we can cache all the reflection elements at startup, and we don't have to access them afterwards anymore. Or we access only the cached ones. So the performance impact is actually pretty small. That's kind of cool because we don't add any garbage collector pressure on the runtime there. And now I want to talk about the testing that we had to do in the previous design. The artist actually, to iterate over, for example, something like the tutorial, he had to create his design in Photoshop, throw it over the fence to the developer. He had to implement it in the engine. He had to create a build. The artist had to wait for that build. And then, worst comes to worst, he actually had to play the game to get to the point where he wanted to see his changes or his design or whatever. So this is a very long process, right? And isolation was pretty impossible to do, like iterating over small details on the elements independently. In our new yeah, that is obviously sad. And in our new architecture, we wanted to solve that issue by something that we call mocking. And that allows us to actually do isolation testing in the editor itself. So what we can do there is the artist can just boot up the screen that he's working on and test it in isolation. So he has fast iteration times. There's almost no dependencies that needs to be loaded, so not the whole game has to run, but only the stuff that is currently visible. And you can still test everything that's going on in there, like events and all kind of stuff. And that makes our artists very happy. But let's look at how this works. So this little demo shows how Olli is now working on this character screen. He has all these various models at his to change values in, but he obviously wants to focus on the ones that are currently looked by this screen. So this is not that much anymore. And now he wants to test how the attack value is visualized if it changes. So he now looks for the attack string in all the available models, and he finds it and changes it to 12, and then actually sends a message into the message bus that I was mentioning before, and then seeing the results that are visualized by the screen. So the screen doesn't care where the message comes from, where the change comes from. Either if it's from the backend or from game logic, we don't care. It's actually behaving the same now. So he can check that the value gets green, that the little arrow appears, and he can make sure that everything looks like he was intending it to be. So that's pretty cool. But does it have some impact on QA? I mentioned that before already. It does. So in our old approach, we actually had to do a lot of manual testing because we had all the different devices, we had all the different features to test, and since our mobile games are going on and on and on forever, this was a repetitive process and very cumbersome. And also it kind of enforced this waterfall process because we wanted obviously all features to be implemented before we actually went into QA phase. So we always had this little buffer of QA phase in the end of a release. And you know what happens if something goes wrong? You need more time, right? So we had the option to either delay or we had to shrink the QA buffer in the end, which then obviously jeopardized the quality. And now we have another problem in the mobile world, and that's called device fragmentation. So how on earth are we supposed to test all the different devices with our games? I found this little picture online that's just showing you the different screen sizes that only Samsung devices are bringing to the world here, right? And I checked up on our Google Play Store entry about our flagship product, Forge of Empires, and it currently supports 13,000 different devices. So that's completely impossible to test each and every one of them, right? So with our previous approach, the manual testing, we obviously had a problem. So based on the mocking that I talked about before, we now go into this automation testing world, where we actually can script behavior that the user does, like button presses, sending messages to the message bus, and all of that is completely automatable. And we can write tests in the end to make sure that the changes that we intended to happen are actually happening. So now we have this kind of testing rig where this automation build is run on. And when we were starting with that, I was like, why isn't everyone doing that? And I was researching, and I found out that companies like Facebook are doing the same. So we are in good company with that, right? And that is just a small portion of their testing rig there. So automation testing obviously makes our QA a lot easier and more convenient because they actually can write tests that are repeated every night and not that they have to wait until the release is done and to make sure that the features are still working the same before. And it also makes regression testing easier. We don't have to only test the features that are new. We can test all the features that are supposed to be there from the beginning of the project, basically. So that's pretty cool. And now I actually managed to have 2 minutes left for the conclusion. I never thought that would be possible, but I'm guessing I'm speaking very fast. So what does this new architecture deliver for us? First of all, we have our developers and artists focus on what they are best at, and that is the design and on the artist side of the screens and the whole user experience, and also the developers who now can actually focus on implementing the features. And one small thing that I had to cut out of the presentation is that this 3-layer architecture that we are enforcing there actually makes it easy to write testable code. So what we end up having was that our unit test coverage suddenly exploded because it turns out that developers don't hate to write unit tests. It's just that when it's hard to write them, no one does it, right? But if it's easy, it's actually super convenient because they can write tests for their logic and prove that the stuff is working as they intended it to do. And they don't have to wait for some artist to come up with a visualization that shows everyone that it works. Yeah. The mocking obviously helps both sides because they now can isolatedly test certain features and visualizations in the editor without having to play the game all the time. And yeah, I was talking about unit tests already. And the UI testing, which is our automation framework, allows us to have an increasingly big set of test cases that makes sure that our game is always running the same way as we wanted it to be, and also that it runs the same on every device and all of these 13,000, and the number is always growing, basically. So yeah, that's pretty cool. And I want to thank you for your attention, and I will be sticking around for questions later if we don't. Oh, that's perfect.
Yeah, so big hand first.
Thank you.
You take a big breath, like you talked fast. Like, questions. We have time for questions. Yes.
Did you have any problems with getting the artists to work in this new way? Like, some artists are not that technical, like dragging that reference for the button in the inspector might be too much for some artists.
Yes, absolutely. It's a change, and it's obviously taking time. And there's artists who are loving to do that because suddenly they are much more independent and they can do whatever in the editor, and they actually dig more into stuff that the developers don't care for because they now can just apply effects independently without even have to ask any developer about that, which is another problem. But yeah, it's always. Change is always a problem with everyone, right? So we have to make sure that we get everyone on board with that new system.